Okay, in the last sessions, we learned how to generalize functions using templates. In these sessions, we will learn about class templates. So let's begin. Just like functions, we can generalize classes as well. Syntax for class templates are same as the function templates. So you start the class definitions by specifying template keywords and class and type parameter T, this one. So here T is a type parameter, and this type parameter is replaced with any type like we saw for type parameter for functions. And it doesn't have to be T. You can use any identifier instead of T, but you have one condition: you cannot use a keyword, already defined keyword in C++ for the type parameter identifier. So rather than that, you can use any identifier for this type parameter. Once you define the class templates, when you declare the objects, you have to explicitly specify the type so that we can fill in for T. I will show you the concrete example in the later slides. Let's look at the concrete example of the class templates first. As we talked about in the previous slides, the template class starts with this line, the template class T syntax. Here we are defining the class name pair, and as you can see here, we replace type with type parameter T. So we put type parameter T here, 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 and here, here, and even here. So normally we specify concrete types such as int, double string, or other class type here. But by specifying type parameter T shown this example, we can generalize the class. So there are two constructor and 4 member functions, and there are 2 member variables as well. And this 2 member variable is type T, which is a type parameter. So these objects, the objects of this pair class should contain a pair of value of type T. So by using this type parameter, we generalize class. So this class can receive int, double, or float, or string values. So that's the reason why we say that we generalize the class. And note that this class, the red color class and blue color class, they are both class, but they have a different meaning. The blue class meaning that we are defining a class. The red color class meaning the type parameters. So even though they both class, don't be confused about this. They have a different meaning. So because we use a template and type parameter T here, we say that this is a template class. And as we saw that there are 2 constructor and 4 member functions in pair classes definitions. So this example shows you how to define constructor and member functions of the template class. As you can see from this example, the member functions of the class are defined in the same way as we define member function for ordinary class. The only different part is that you start with a template syntax and uses a type parameter T. So for example, for the constructor, it starts with a template syntax, and for the ordinary constructor, you specify the class name with a scope resolution operator like this. But here we also uses the scope resolutions, but we specify the type parameter within this angle brackets like this. And we also uses the type parameter for the argument type as well. So the constructor for ordinary class do not specify this type parameter. It only specifies the class name, which is a pair. But because this is the constructor for the template class, we also put the type parameter T before the class name. And we uses the type of the parameters using a T. So that is the different parts. The other parts are exactly the same for defining ordinary classes constructor. Similar for defining member functions. The member function also starts with a template keywords. And it also uses a scope resolutions operator to specify the class name where these member functions belonging to. But instead of just putting the class name here, we also put the type parameter T here. And we also use a type parameter for the parameter argument type as well. So this is how you define constructors and member functions of your template class. So they are very similar for defining constructor and member functions of the ordinary class. The only different part is you start with a template keywords, and you also specify the type parameters within angle brackets when you are specifying the class name and type of the parameters. That is the only different part. Other parts are the same. And once the class template is defined, you can declare the objects of the template class like this syntax. Put your class name here and specify the type within angle bracket and specify the name of the objects. The type you specify here, for example, int and char, will be used to replace the type parameter T. So this score object will store the pair of integers, and the sit object will store the pair of characters. So if we go back to a few slides, this pair class has a two-member variable, type T. T is a type parameter. So by putting this int here, this T is changed to int. So the first object will store the two int type of value in first and second member variable. The second object is a char, so T will be changed to char, and the sit object will store the two character types of values in the member variable first and second. So can you say that we generalize the class using a class template? This pair class works for both int types and character types of values. So that is the reason why we say that we generalize this pair class. And once you define the class and declare the objects like this, you can use the objects just like any other objects for ordinary classes. So for example, if you look at this, using the score objects, we are calling a set first member function. using dot operators. Nothing new here. This is the way we call the member functions of ordinary class. So the syntax for calling the member function using objects of the class using objects of the template class is same. I have already explained these steps in previous slides, so let me briefly summarize this. The definitions of member functions of template class is also template itself. So we start with a template keyword. So if you look at this constructor and the member function also itself a template, so we start with a template keywords. And we saw that we just not use the class name, but we also have to specify the type parameter using angle brackets. So like this, for the ordinary classes constructor or member function, you just put the class name. But for the template class, you also have to put the type parameter as well. So yeah, that's it for these slides. And note that we can also use the name of a class template as the type for a function parameters. So this example, add functions receive one argument of pair objects that stores the pair of integers. Because we specify the int here, the type parameter will be replaced with int. So the pair is a template class we defined in previous slides. By specifying int here, the type parameter t will be replaced to int. So these objects will store the int type of values. So these adder functions receive the objects of pair class type, which stores the int types of values. We can generalize these functions further. So like this, you could define the function templates for these adder functions. Here we are declaring the type parameter t, and we can use this t to generalize these adder functions. So this is the generalized version of adder functions. Its return type is a t, and previous example, its return type was int, and we specify int for the pair class type. But here we specify t for return type of these adder functions, and we also specify t here for this pair class type. So these functions can return any type, and this function also receive objects of class pair type, which stores any types of values. So we generalize this adder function. In previous example, the adder function only returns int type, and it only receives the objects of pair class which stores integer values, but now it can receive the objects of class pair type which stores any types, because we use a type parameter t here. But like we discussed in the function template sessions, not all types can be substituted for type parameter t. You can only use a reasonable type. For our example code, the pair template class we defined in the previous slide, it uses the assignment operators to set the member variables from the member functions. So the reasonable type for the pair template class is the type that works correctly with assignment operators. And the copy constructor must also work well with that type as well, because class has a copy constructor. And since there are member functions with call by value parameter of type T in the pair class, if type parameter T involves pointers and dynamic variables, then there should be suitable destructors as well. So this is same issue as function templates. Whether it is function templates or class templates, not all types are applicable. Which types are applicable is depends on your functions and classes. So let me show you the demo code for the class templates. Okay, this is the demo code. Let me explain you about this code first. So we have 3 classes here. The first one here, the second one here. We don't need this one. Let me make this code simple. So we have 2 classes here, int count and double count. The class name int count has a 1 member variable count, which is int type, and it has a constructor setting the member variable count to 0, and it has 2 member functions. The get count returns this count member variable, and set count sets the value of this member variable. Here we have another class which is called double count. This class also has a member variable count, same as the int count, but the type is different. Its type is double, and this type is int, and it also has a constructor. And same for this double count. It has a get count and set count member function, which is exactly the same as the int count class. Get count returns the value of count member variable, so this one returns double, but this one returns int. The only different part is this one, return type int and double. And set count, the only different part is this type of the parameter. Set count functions for the double count class receive double types of values, but the set count member functions for int count class receiving type of value. So that is the only different part. As you can see here, these 2 classes does very similar things. Setting the values and returning the values. Setting the values, returning the values. Does very similar things. The only difference is that this class deals with int type of values. This class deals with double types of value. That is the only difference parts between these 2 classes. We can do this. There's syntactically correct, but this looks inefficient because there are many duplicate codes. I see they are duplicate codes. This one is also duplicate code, and this one is also duplicate code. The only different part is these return types and parameter types. And the type of the member variable is the difference. But if we can create one class can hold this int and double values then we can make the code more simpler. We can do that by generalizing these two classes using a template. So this is how you do this, how you create the template class. So we learned that in order to create the template class, you first start with a template keywords and specify the type parameter t here. And this time the class name is a counter. And this class also has a member variable counter, just like this double counter and int counter. And just like a double count, int count, this counter class also has a constructor and get count and set count functions. The only difference is that instead of putting the doubles or int here, we put the type parameter t here. So double count, the type of this member variable is double, and for the int count class, the type of this count member variable int count is int, but for this counter class, we put the type parameter t. And we also put type parameter t here for return types and for the parameter type t here. So by specifying, so by creating template class counter, this class template class counter can hold both double and int types. So if you look at these main functions, we are declaring the objects for this counter template class, but here we specify int and we specify double here. So for this int c and t objects, the t will be replaced to int. So this object will store the int. So this int c and t object will store the int types of values in this count member variable. For this one, double c and t, this double is replaced with by, so this t is replaced by double. So these objects will store the double type of values. So now you don't need these two class. You only need this one class to represent both int and double. If you don't have this templates class, you have to create a separate class for each type double and int. If you want to use another types, for example, if you want to use character types, you have to do something like char like this. You have to create another class. But for template classes, you don't need to create another class. All you need to do is just specify char here. You can do that. So for these objects, the t will be replaced with char because we specify char here. So if we don't have a template class, you have to create 3 objects, but by generalizing this class, we only need 1 template class. And by the way, you can use whether this template class T syntax. You can also use a template, this type name T syntax. It's your choice whether you use a type name here or class here. They both compile correctly. So if I compile this program, template class, this compiles well, but it does nothing because we only declare the objects. And this class keyword also compiles well as well. So if we compile this, it compiles well. So whether you use a type name and class name, it's your preference. So let's go back to the slides. Okay. Okay, now let's talk about the inheritance. So we learned inheritance concept before. We learned that child class can inherit the properties of parent class. And by doing that, we can remove duplicate code and design the classes more simpler. We can also inherit the template class as well, because template class is also a class. The derived class, which is a child class, can inherit the template class or non-template class. If derived class inherits the template class, the derived class itself becomes the template class as well. There's nothing new here. Inheriting template class is very similar to inheriting ordinary class. So let me explain you inheriting template class using a demo code. Okay, this is the first example of inheriting template class. So we have a parent class here and child class here. And child class inherits the parent class here. The syntax for inheriting classes is same as ordinary class. You put the colon and visibility modifier here and put the parents class. This example class parents is a template class because it starts with a template keywords and uses a type parameter t here. On the other hand, the child class is an ordinary class. So this example shows how ordinary class inherits the template class. So parents is a template class. So this child class inherits this parents template class. The syntax for inheriting class is same. Put colon, public visibility here, and put the parents class name. But if you wanna inherit the template class, you also have to put this one as well. Type within angle brackets. And so this type will be replaced, this t will be replaced by int here. And the child class has a constructor here. It receives one argument, type int, and this child class constructor calls the parent class constructor, which is this one. And as you can see here, we also put the type here within open and close angle brackets and passes the first argument to the parents constructors. So this is how you inherit the template class from ordinary class. It's same, but you have to put this type. So if you look at the main functions, we are declaring the objects of the child class, and we're giving a 10. So, and we're calling the member functions print, which is defined in the parents class. The child class inherits these member functions from this parents template class. So you can call these print functions. This line should print 10 because we initialize this object with a 10 here. The 10 will goes here, and this 10 will goes into the parents classes constructor, which is this one. And because we specify int here, this t will be changed to int, and var member variable, this will be also changed to int because we specify int here. So the 10 comes here, 10 will be stored as var. And this print member function just print var, so this one should print 10. So it compiles well. If we run it as expected, it prints 10. So this is how you inherit the template class from the ordinary class. Let me show you another example. So this time, the class parent is also template class. It's exactly the same as before. The child class also inherits the parents class, but this time child class is also template class. In the previous example, child class was a ordinary class, but now it is a template class because it also starts with a template keywords and declaring the type variable z. So this example will show you how you inherit template class from another template class. So same for this part. The only difference is that you specify type parameter z here. So in the previous example, we specify int here, but because now the child class is also template class, you put the type parameter here. And here as well, you put the type parameter here and here. That's the only different part. And now, because child is a template class, you can declare the object of this child class like this way. So you can specify int here. So this object 1 stores the value of int, and this object 2 can store the values of type double. So this object 1 initialized with 10, this object 2 is initialized with 10.20, which is a type double. And here we are printing member variable of object 1, and here we are printing member variable of object 2. So this line should print 10, just like our previous example, because we are initializing object 1 with 10. This one should print 10.20. So let's compile this program and see whether the function, the program works as expected. As expected, this program prints 10 and 10.2. So this is how you inherit the template class from another template class. Remember that you put the type parameter here as well. Okay, so let's go back to the slides. So we saw this demo code. Let me introduce you new features in C++, which is using keyword. Using is very similar to typedef keyword. Oops, sorry, typedef keyword. You have probably already learned typedef keyword before in C programming class. To recall it, typedef is used to give a new name to a type. So for example, here, we are giving a new name to int type. The new name is a myInt. So after this line, you can use a myInt for representing the int type of values. So that's typedef keyword. So just like primitive type shown here, int, you can also use a typedef keywords to give new name to the type using templates like this. So pair is the template class we defined in the previous slides. We are specifying int for type parameter. So this type of objects will store the pair of integer values. So after this line, you can use this name pair of int to represent this type, pair and angle int. So if we look at this example, the pair of int is declared here. So pair 1 and pair 2 is the objects of pair class, which stores the integer values, this one. Instead of using a type def, you can use a using keyword, which is newly introduced in C++11. The syntax is that you put the using keyword here and specify the new name for the type, and you put the original type name here. So it's like you're assigning an original type to a new type name of variable. So this effect is, the effect of using is same as type def. So after this line, you can use pair of float to represent this type. The objects of pair class type, which stores the float values. So it's shown here, f pair 1 and f pair 2 is declared with this pair of float. This one, which is equivalent to this pair float. So the effect of type def and using is same. They are both used to define new name for the type. So what is the difference between type name and using keyword? So what is the difference? Their effect is same in a way that they can define new name for the type. So what's the difference? The only difference is that with using keyword, we can use a template, but you cannot use a template with a type def keyword. So if you look at this example, with using keyword, we can use a template here like this, and we can use a type parameters. So after this line, you can use this name, pair of num, to represent this type, pair and t, which is a type parameter. So here we are declaring pair of nums, and now we are putting float here and name here. So this one represents this type. So with using keyword, we can use a template. But for the type def keyword, you cannot use a template. So you cannot use a type parameter t like using keyword example here. So you have to specify the type, exact type here. So this pair of int is a new name for this type. So we are using this here. So this object is type of this one. So that's the different things. With using keyword, you can use a template and type parameter t, but with a type def, you cannot use a type parameter t. You have to specify the actual type. Let me briefly show you the demo code for utilizing using keyword. This is the demo code. This part of the code is exactly the same as the previous demo code, so I'm not going to explain this. The only different part is this: we added these two lines. Here we are using keyword to define new type name, pair of num, which represent this one. Counter in type parameter with templates v is a type parameter v here. So after this line, we can use this new name to represent this type. So let me delete this line. We are using this new name and we are passing the type here. So this int2 object is a object of this counter class, which stores the int type of value, because this is the counter class. This t will replace it with this int. So by calling this setCount member functions, we stores the count member variable to 30, and by using a get count value, we are getting this count value and printing using a this cout. So this line should print 30. And here we also use a pair of nums. The new name we define using this keyword, but this time we are specifying double here. So this object stores the double values. So by calling this setCount member functions, we can store the 30.50 to this count member function, which is a type double because we specify double here. And we're printing the member variable of this count. So let me compile this program and see the output. Save this one first. This is not a compiler error, it's warnings. This warning is due to utilizing this using keyword. This using keyword is introduced in C++ 11. So if I specify the class name here, I mean the C++ version number here, the warning should goes off. As you can see now, there is no warning, and if I run this program as we expected, this program prints 30 and 30.5. So this is how you use using keyword. And note that you cannot do type def counter v off. You cannot do this with type def keyword. You cannot use this type parameter. You have to explicitly specify type like this one, or like this. So that is the difference between using and type def keywords. Let's go back to the slides. Okay, let me summarize this week's lectures. We first learned the function templates, and we also learned the class templates. So using a template, we saw how to generalize functions and classes. And by generalizing function and classes, we can remove some of the duplicate codes. And we also learn how to inherit the class templates. We learn how to inherit template class from ordinary class. And we also learn how to inherit template class from another template class. And we also learn the differences between using and type def keywords. With using keyword, you can define the new name of the type using a template, but for the type def keyword, you cannot use a template keyword. So that's it for this week. See you in the next week.